Good morning, guys. Happy Friday. We've made it to the weekend. Unfortunately, it's only a 2-day weekend, but the good news is that we've got it's college football season. So, good things are happening. Anyway, so also, kind of new thing you'll see is that I attached a Google Form survey. So if you guys will fill out this Google Form survey, the whole point is just to give me feedback on how I'm doing and how, more importantly, how you guys are doing, because that determines how I'm doing. So if you'll answer that honestly, I would really appreciate it. Don't be too honest, like brutally honest or anything like that. But no, I can take it. I can take your feedback. It's all right. So yeah, if you'll answer that for me, just want to know some things like your stress level, how these videos are working for you, any recommendations that you guys have for these videos or the assignments or anything like that. Luckily, half of you guys were able to come by the school yesterday and pick up your calculators and textbooks, so that went really, really well. So we didn't have to put that off anymore. Also, if the other half of you guys want to message me today, I'll be at the school from 9 o'clock to 3 o'clock. Or if you can't make it, I probably will be at the school over the weekend, or we can just do Monday 9 to 3 o'clock as well. So just depends on how bad you guys want the textbook. Textbooks, you got the odd problems in the back of the book, so I don't have to post solutions anymore, which is so nice. And then during live office hours every school day at 1 o'clock, I can go through all the even problems with you. So I can literally go through all the problems on the homework. And it's probably even better if you go through the problems with me live, because I can ask you questions and get you to start thinking the right way and start understanding kind of the concepts better than just making the videos. So it is still a lot better to actually have that live interaction with you guys. And it'll be better for your learning and your understanding as well, because I can give you immediate feedback and kind of correct some misconceptions that you might be forming. Okay, so some of you guys, the videos work just fine. You don't need the live office hours, but you might think about joining just so you can probe and ask questions. And seriously, it'll be really good for you, and it's good for me too. So without any further ado, let's get started. So today's lecture will be very short because we have a longer assignment, but I do want to kind of go over the same thing we went over before. Remember, we were graphing the average daily wind speeds, and if we graph the wind speeds as it changes over time in real time, we would get some funky graph here. It kind of looks like a seismograph or whatever, but you can see it's pretty unstable. It's wind speeds are fluctuating. So even by taking the average daily wind speed, that is a statistic, because it's a summary of the overall incoming real time wind speed. So even just if we took an average for each day, as that goes up and it goes down, that is a form of a statistic. All right, so we graph the average daily wind speeds, and this is going to be the average daily wind speed for the whole year. So it's one histogram. We do get good information from this. We can tell what a typical day, what kind of winds we would expect, anywhere from 1 to 3 miles an hour on an average. We can see some outliers. There were at least a few days that had over 5.5 mile an hour winds. Some storms came in, really, and then there was that really crazy day we talked about before, right? We can tell the overall shape of the distribution is skewed to the right. We can even tell that from our box plot down here, right? Because our right whisker, or the whisker on the right side, is larger than the one on the left. Also, the outliers is going to skew the data to the right as well, so we have to use the median and the interquartile range. So we're looking at the 5-number summary, not the standard deviation and not the mean, because the mean is going to be skewed to the right, and the standard deviation is going to be much larger because of the deviations from our outliers. Okay, so it would not be appropriate to summarize the data. We could break it down instead of just one overall year. We could look at half the year in seasons, so in the summer and the winter months. And we can even compare. When we're only comparing two, you can compare two histograms side by side. I kind of actually prefer to look at it like this, where one's hollowed out, because then you can line it up. Make sure, again, your x-axes are the same and your y-axes are the same as well. I said those backwards, but you get it. So that's not stretched out or stretched up high or something like that. And whenever you're comparing, again, we can't use the mean and standard deviation because both of these are skewed right. Actually, if we were looking at this one and we didn't have that outlier, it's still skewed to the right. We could almost get away with using a bell curve, but nope. We'll actually start bell curves next week, but we're going to have we're going to do a practice quiz on Monday when we come back, and then a review on Tuesday, and then we're going to take a quiz on Wednesday. So this would be a really good time to get caught up on your homework. That kind of goes without being said, but you're going to be caught up on your homework because we are going to take that quiz on Wednesday, and then a test the next Wednesday or the next Friday. And all the unit one, which is going to be the first 5 chapters, assignments are going to be due when we take that test. I'm not going to take any more late work after that. Okay, so if you get a 0, it's a 0, and that's just going to stay that way. And I'll put them all in the grade book as well for you. Okay, so make sure you're getting caught up, and we're trying to do our assignments daily and stuff like that, all of our good practice. And if you are behind, you can ask questions during the live office hours. Like, that's how you're going to get caught up, by the way. Come to live office hours. I'll work the problems with you so that you're not struggling on your own, and we'll get you caught up. You can ask questions from any assignment. It's good review for everyone else too. So don't be afraid to come to live office hours. Typically, recently, there hasn't been that many people there, so you're more likely to have good one-on-one time, and you'll have my undivided attention. So it's good for everyone. All right, so instead of breaking it down by 2, we can also break it down by month. So January through December. So we kind of talked about this before, and this line here was the overall. So when we did the whole year, there were some outliers here that would have been considered typical, but it was very unusual for July to have such high wind speeds, even though it was only 2, which would have been, close to the median for the overall year. All right, so then even better than this data, and this is an improvement, right? Oh yeah, by the way, also when we have 12 histograms, these are box plots, of course, but if we had 12 histograms, we could not compare them side by side like we can when we only have 2. So after a while, even though it's nice to see the histogram so you can see the actual shape, we can still kind of get the shape from the box plots. It's just not as precise, right? We have to make some assumptions, and you can see the overall trends as time goes on. But even better, and this is where we're going to go to the next one, is something called a time plot. Now, a time plot is a form of a scatter plot. And what we're actually graphing out are all 365 days as we go on. And you can see that it's obviously, you can see your spread. It's going up and down, just like we would see in a normal, kind of looks sporadic like we did with the original one that was just graphing the week as it went on real time. You can see the general trends here really well. The same general trend. It goes down and calms down in the summer, and then it goes back up during the winter and the autumn months. Kind of the same trend we see here, except this is actually kind of nice because we see the actual data. Even better than this, we could do an overlap. This is getting a little busy, but it's fun and I could do it. So just kind of removing backgrounds so it'll overlay images, which is it's fun. I entertain myself. So you can see the summary of this month, February. All the data that's in this blue box here is being summarized by that box plot. So it's kind of cool to see the box plot overlaying the actual data itself. And we could break down, this would be January's data. You can see the outlier, the maximum. Same thing here. You can see our 2 points here. Now, they're all going to be kind of graphed out linearly, but keep in mind this is going from the beginning of the month to the end of the month. And that's why they don't line up completely like this one did and that one almost did. Same thing. Oops, I should probably lock that one in place so it doesn't move. All right, same thing going on here. There's a lot of data towards the low end, right? So that's why our that quartile is so small and so close to the median, right? And then it starts spreading out more. So we could tell the data was skewed from either the scatter plot. You can even see it from the histogram, which is kind of cool. Or not the histogram, the box plot. You can see your outlier here for July. It's really consistent, right? And that's kind of what we were seeing with the box plot too, because the IQR and the range was so small as well. That means all the dots were really close together, which is just like what we would expect. Kind of some crazy stuff going on over here. You get the idea. Kind of fun stuff. Okay, so that's it, really. I got one more new thing, which is an ogive problem. We're going to do that on the assignment. So I'm going to do 3 problems with you. So if you'll go ahead and get out your assignment. Nice and short and easy lecture. I'll try to do all the announcement stuff at the beginning. That way I can give you a timestamp so you don't have to listen to the announcements and me go on about random stuff in the middle of the lecture like I'm doing right now. All right, so here are our summary statistics for Mooseburgers and McTofu, which are fictionary places. And here are the salaries, I guess, weekly or average daily salary per person. I'm not sure how the problem is set up, but that's okay. Here we have, we're given this list and we want to actually first come up with a 5-number summary. And we don't want to arrange those in order and then find the median and then the middle point and do the 50 percentile. We don't want to do any of that stuff. So what we're going to do is we're going to put it in our calculator, which now we have our calculator because we either picked it up yesterday or you arranged a time to pick it up with me. Oh yeah, by the way, I am at the school pretty much the whole day, but if you would just give me a heads up before you head out or something, like 10 minutes or something, then I can make sure that I'm out there and you don't have to wait on me, or I don't have to worry about missing it. Or yeah, or if you know when you're going to be there, just give me a time. If you have to change that time closer to it because you're running late or something, it doesn't matter. Just hit me up on Remind. All right, so we need to put all this data into our calculator. So we're going to go to Stat and then Edit. And I've actually already put it all in, but just enter all of your data for list 1 for Mooseburger. And then for list 2, you can do all your data for McTofu, which sounds absolutely disgusting. All right, then we want to go to the Stat button. We have our own button for statistics because we're such a big deal. TI-89 does not have a stat button because it doesn't have all the stat functions in it, and that's why we use the 84s. The TI-89s are really more for engineering. So then we're going to arrow over to the right to the Calculate tab, and then we're going to do one variable statistics, and we're going to do our list 1 first. So we do second 1, that's the list 1, the little blue one there, and then you can just hit enter twice. We're going to leave the list frequency list blank because we're not using a frequency list. Here's our mean, our average, which is going to be 134.4. That's the average salary for the Mooseburger employees. The S of X is the standard deviation of X. I wish they would do SD, but it's the S of X, which is 14. That's 0.68. That's our standard deviation. The sigma, okay, lowercase sigma, that is the uppercase sigma, the sum, summation, if you're used to that in upper level math. Anyway, the sigma of X is going to be the standard deviation for a population. In case we did a census where we weren't taking a sample, we actually knew the entire population, but that rarely happens, so we always use the S of X. I'm going to arrow all the way down to the bottom. That's our 5-number summary: minimum, first quartile, medium, third quartile, maximum, which is what I filled in here. We're going to do the same thing for McTofu. So I'm going to go to Stat, arrow to the right to Calculate, and then I'm going to do second and then list 2. Go down to Calculate, same thing. Yeah, by the way, our average is pretty similar, should be pretty similar. And our standard deviation is much larger. What would make our standard deviation so much larger? I don't know. If we look at our data, do you see anything that sticks out? You really see it whenever I graph the 5-number summaries and the box plots. We got this outlier, this 360. So that 360 is going to do a few things. One, it's going to drastically increase our standard deviation because the deviation from the mean of 134 is about 200 instead of a deviation of like 20 on average or whatever, or 14 or whatever it was. I don't even remember. So yeah, it's going to be drastically increased. So we went from a standard deviation of 14 all the way to 73 from 1 point. One outlier did that. That's why we can't use the standard deviation. Instead, we have to use the IQR. All right, also the median is 120. The median's not going to be impacted by whatever happened at the 100th percentile. The first 99 percentile is going to be exactly the same. It's just that the 100th percentile or whatever, that's going to be far to the right. All right, so that's all of our data there. Good to go. Next thing we want to do is graph out our side-by-side box plots. So I labeled this one Mooseburgers or just MB. And first thing I'm going to do is graph the box. So I'm going to go from 123 all the way over to 144. Then 133 is pretty well right in the middle of that. And then my minimum, the whisker, is going to go to 110. The maximum is going to go to 160 for the right whisker. And then for McTofu, we're going to do the same thing. So graph your box from first quartile to third. The median is pretty well halfway between, but slightly to the left. And then minimum's 100. That one's easy to figure out. And then the maximum for this one. Okay, so for the maximum, what we're going to end up doing is finding the interquartile range and then graphing a point to the highest. Oh no, we don't have to do that because we know what the maximum is. Clearly this one's going to be an outlier. So our whisker is not going to go all the way to the outlier. It's going to go to the next highest one. So the next highest point, if we look here, is going to be 146. Okay, so we want to graph this whisker for McTofu. Yeah, I even did this wrong. It's going to be 146, which will be about right there. Yep, that'll work. I'm way too much of a perfectionist. I need to get over it. Anyway, so that's how far the right whisker is going to go, and then our outlier is going to be way out. Okay, so we created our parallel box plots. We labeled them clearly. We have our axes labeled already, and we have McTofu and or Mooseburger. Which restaurant pays the typical employee more? So if we're looking for the typical employee, we're going to be looking at our inner quartile here. So if we look at the range of the inner quartile and the range of the inner quartile, which one of these boxes are further to the right in general? Well, that's going to be Mooseburger, right? So Mooseburger is going to pay their typical employee more than McTofu. Then number 4 says McTofu advertises they have a higher average salary, keyword average, not a higher median salary, but a higher average salary. It's sad because you always hear about averages, but a lot of times we should actually use medians when the data is not unimodal and symmetric, right? So in this case, McTofu, even though clearly they don't pay as much as Mooseburgers for their typical employee, that one person, Sally, she got really lucky, I guess. Yeah, why is the higher average salary misleading? What happened? What does this outlier do to our average? It's going to skew it and pull it to the right, right? Because again, deviation from this is so high from what we would typically see. It's going to move the standard deviation really high, and it's going to make our average higher. And it even made our average higher than the average for Mooseburger. And if we didn't have these outliers, we probably could use the mean and standard deviation, because our distributions look like they're symmetric, right? And in fact, the medians are almost exactly in between the range of the inner quartiles, and the whisker for the left and the right are almost exactly the same length as well. Maybe on this one you can see this whisker is a little bit longer than the left one, but we could have used the mean and standard deviation if it wasn't for this outlier. And if by chance this outlier was a typo, like if this was supposed to be 136 instead of 360, if we went back and we asked salaries like, did you put that in right? And we figure out what it was, we can fix it. We can note what happened or whatever, or we can just simply omit it if we are honest in our findings, or if we're honest in our conclusion of a report or whatever we write, and we tell people what that we removed it. So that's fine. All right, let's do another problem here. Ozone levels and parts per billion, ppb, were recorded in sites in New Jersey monthly between 1926 and 1971. Here are the box plots for the data for each month over the 46 years, lined up in order from January, which is 1, so the first month, all the way to December, the 12th month. And what month has the highest ozone level ever recorded? So we're looking for the maximum for all of it, and not necessarily going to be an outlier, but it is in this case the 4th month, so that would be April. Which month has the largest interquartile range? So we're looking at the box. Man, I mean, my eyes were drawn right to it, right? So that would be February. February has the largest interquartile range. Which month has the smallest range? It looks like it might be a tie between June and July. Maybe July is slightly smaller. Write brief description about the ozone levels in January and June. So January is 1, June is 6. So it looks like they're centered about the same, right? The median and the boxes are about level, but the biggest difference I see between January and June is the spread, right? January is going to have a wide spread from the whiskers and the IQR, but June is really consistent for their ozone levels. They're very consistent. In fact, the IQR is so small that these values are considered outliers, because the 1.5 times that going to our whiskers, if the box is small, it's going to draw the maximum the whiskers can be to be small as well. So those are tied together. So it's not, these are unusual for that month, but they're not necessarily that far away from the median, because we just had more spread in general in January. Write a report about the annual patterns you see in the ozone levels. So just looking at a general trend, it looks sinusoidal, right? So it's going up and it's going down and going back up. So it looks like a sine wave. That's what I mean by sinusoidal. If you haven't taken trig, and if your geometry teacher didn't graph it out for you, which I did. Anyway, it's kind of fun. So yeah, it's sinusoidal, which happens in simple harmonic motion like pendulum movement or oscillating weight on a spring and stuff like that. So you'll see that quite often in mathematics. But basically it just means that it's going back and forth, just like the heat is going back and forth. Could I figure out why pollution levels were higher in the spring and then went down in the fall? Well, the weather in the spring is about the same as the weather in the fall, so I don't know why one would be high and one would be low. You would expect I don't know, maybe in the summer there's more energy usage, or maybe in the way that we heat things might be different in the winter using gas versus burning coal to generate electricity or something like they do in China in the summer months, which would cause more pollution. I don't know. So all I can really go off of is the data here, but we would say there's a sinusoidal wave pattern going on. There's more variability in the early months than there is in the summer, and even the variability we have in the late months. And most of the displays look to be symmetrical, where the medians are in the center, except this one of the IQR, and the whiskers are the same lengths on both sides. There don't seem to be too many outliers, but there are some outliers. There's no far outliers though. All right, so you don't have to write all that, just some, whatever you see. All right, and this one's really important because I'm going to teach you about an ogive. The first year I taught stats, so that was, yeah, Ashley, your sister was there, but I actually totally missed ogives, and it didn't show up till the end of the year. I was like, oh man, these are kind of cool. I need to teach you about this. So I got a really good one, 2 problems for you. It's pretty simple. So what an ogive does is it actually gives you the data plotted out where it gives you the cumulative percentages as you go. So the percentiles, in other words. So here you have the cumulative percentage, which is your percentile ranking. And on the right, you have the actual data itself. So it looks like they followed or recorded data from 1,400 men. I'm assuming they're American men, but they don't say. You could probably look into it, whatever the Framingham Heart Study, I don't know. It might be local, it might be national. But anyway, 1,400 men. And they recorded their cholesterol levels. So what we want to do, estimate the median cholesterol. So the median is the 50th percentile, and I actually plotted these points here. So the 50th percentile, okay, is going to be a median of about, I'm guessing about 100, and there's 75 in between there, so that might be 130, maybe 128, something like that. So the middle 50%, so 50% of men had lower cholesterol levels and 50% of men had higher cholesterol levels, would be at 100 and about 130 or 230 cholesterol milligrams per DL, whatever that stands for. I don't know. Estimate the quartiles. So quartiles, that's going to be 25%. So 30 is halfway between those two, and then halfway there. So that's going to be, I'm not sure, about 200. And then the median we already did, third quartile, is going to be right here. So halfway is 70, then halfway again 75. That looks like that's going to be about halfway between 75. We'll just do, instead I'll do 40. So about 265. Estimate the range in the IQR. Well, the range from the maximum to the lowest value looks like we're going from, I'm going to guess about 400 is the highest, which sounds really bad. 400 to about 100 and just 100. So that's got an overall range of 300, but we never use range because it's drastically impacted by outliers. So instead we use the IQR. So the IQR looks to be about the width of the bends here, which is 75. So that was easy. Create a box plot of the speeds above the ogive. That's what we've been looking at, which is kind of nice. The ogive is nice to see. I mean, we're not used to reading it, but you can find out where any percentile you want to find. You can find out where that ranking is. So if you also know where you're at, you can find out where your percentile would have been. So ogives are really, man, they're kind of easy to work with. Actually, all these lines you see here, I added all those. So can you imagine how hard it would be to read this if you didn't have those lines? Yeah, you're welcome. I don't know why they don't just give that to you, because yeah, anyway, so those guiding lines are really helpful. Write a few sentences about the cholesterol levels of these men. Oh, so yeah, our box plot is here. If we did 1.5 times the IQR, that's going to be this blue line. You don't actually include the blue line. I'm just visually showing you what we're doing when we do a right fence and a left fence. So 1.5 times the IQR added to the third quartile will be our right fence, and anything beyond that's an outlier. That's why they're marked, and the whisker doesn't go that far. And then subtract that value, 1.5 times the IQR, from the first quartile, and that'll tell you your left fence, which it looks like there was no data below that value. So we're good to go. And that's our box plot. Write a few sentences about the cholesterol levels of the men. So looking at the box plot, we can tell it looks symmetrical, right? but because the median is in the middle of the interquartile. Also, the length of the whiskers are about the same, but the only reason the whiskers are the same is because these outliers weren't counted. Okay, so it is going to be skewed to the right by the outliers, but if we didn't have these outliers, these men, of course, that because you can always get bigger, right? Your cholesterol levels, I guess at some point, that's kind of a crude joke, but your cholesterol levels can only get so low and only so high as well. So there are kind of natural limits there. Before there's a joke I want to say, but it's insensitive, so I'm not going to say it. See, I'm mature. That's amazing. 2 years ago I would have said it. Anyway, or maybe it's because I'm recording this and it's going live on YouTube, so whatever. Good stuff. Write a few sentences about the cholesterol levels of the men. So it looks just slightly skewed to the right by the outliers is the main issue. But if it weren't for those outliers, we could actually probably use a bell curve pretty well with this, because it's more or less symmetrical and unimodal, of course. I don't really have anything else to say. You could say the range. You could in the sentences you could tell what you can give the median. You can give the interquartile range. That would be appropriate to write about as well. All right, so that's it. We are at 27 minutes, and 26 minutes because I cut some of that stuff out. But anyway, I hope you guys have a wonderful weekend. Again, make sure that you're getting caught up. If you're getting too far behind, you need to be taking advantage of those live office hours. Like, honestly, I'm here. I'm available. I want to help you. Also, make use of the textbook. It's got chapter summaries in the back, which is really helpful. And the odd problems are all in the back of the book as well, so you can see the solutions. I understand the frustration with statistics. Oh yeah, by the way, give me your feedback. Be honest with the feedback. And if you want to talk through some of your frustration, that's totally fine too, because I promise you, I know this course can be frustrating. It's a lot of vocab. There's not like there's one right answer. It matters more about how you defend your answers and your opinions in other ways, and how you feel about something. And I'm not used to writing about my feelings. I'm not good with my feelings, so I don't show my feelings. So I get it. This course is a little difficult. Like I said, there's a lot of vocabulary. It's kind of it seems really subjective. Kind of one person might think it's symmetrical and the other person's like, no, I don't see that. So we just need to be able to talk through what we're thinking. But I promise you it'll get better as we keep going. You'll get more used to the vocab and kind of how all this stuff works. So, and I've got really good visuals to be able to show you guys. So anyway, that's all I got to say about that, and see you guys. Have a good day.